Hey, welcome to Rock Studios. Bring broadcast live from the show floor here at Automation Fair in Anaheim, California. My name is Andrew Ellis, and I get to present or host two sessions this week. One being what we're talking about today, both really focusing on artificial intelligence. The first today really talking about our vision and strategy, and then the second later this afternoon talking about the products and solutions that we will be looking at. If you have any questions that you want to chat in, please chat them in through the LinkedIn tool. And I'll say joining me is Jordan Reynolds. Maybe Jordan, quick intro for yourself.
Absolutely. Great to be here. Jordan Reynolds, I'm based in Austin, Texas, Vice President of AI and Autonomy at Rockwell Automation.
Fantastic, thanks Jordan. I'm going to start with this. You know, every year Rockwell Automation produces the State of Smart Manufacturing reports where we survey our customers and we ask them their level of adoption of smart manufacturing, like how well is it going, what are the technologies they're choosing, what are the hurdles they have, what are the positives they're seeing from it. And one of the questions we asked this year was their level of adoption of artificial intelligence and machine learning. Essentially, how many have either adopted it or will adopt it in the near future? And it was pretty much an astounding number. 85% either said they had, implemented something in production or as a proof of concept, or will in the next 20 or 12 months, I should say. The follow-up question, which I think is just as important, was over the next 12 months, where do they see investing? Where are they going to invest in technology? The number one answer, generative AI, causal AI. And at number 6 was AI and machine learning. So there is a real hunger for this technology and a real race to capitalize on what AI can promise. So with that, I'd really like to ask, before we dive into kind of the vision of where we want to go, I think it's so important to level set on what do those words even mean? What does the technology mean? So maybe Jordan, you can help with what is generative AI, causal AI in an industrial application?
Yeah, for sure. I mean, so I'll start with causal first because it sort of represents the traditional style or methodology of applying machine learning or artificial intelligence to a problem really before the emergence of generative AI techniques, which have taken up a lot of attention these days for obvious reasons, right? They're very valuable. But causal AI generally refers to you are attempting to learn a model that approximates a relationship between two variables, right? In the most basic form. It can be more than two variables, but in the most basic form you have like some sort of an input variable or a causal variable, and then you have an output variable like a response variable. And the idea is you don't know if or how the input causes or influences the output, so you need to learn the relationship between them, right? And what you're essentially learning is the way that some input like X influences some output like Y. And this is extremely valuable because if there are, in a really dynamic, complex, multivariable scenario like an industrial automation process, there's lots of different variables like environmental parameters and disturbances and material variations and differences in process parameters, and all of these variables aggregate together to cause a product to be high quality or low quality or exhibit some level of quality along the way, right? And you may need to learn some sort of a analytical understanding of how all these process parameters and recipes cause a product to have the right level of quality. That's a great application for traditional forms of causal machine learning, right? These things have sort of a characteristic where they're deterministic, so the same input is always going to produce the same output, so that gives them a level of reliability and determinism so that they can be used in like safety critical manufacturing scenarios, especially if they're accurate. Generative AI is a little bit different. Generative AI doesn't necessarily worry about causes and effects or relationships between variables. What it's attempting to do is match or mimic the distribution of a bunch of content that it has exposure to so that it can generate new content with similar distributions, right? So for example, if I if I train a generative AI model with a bunch of human language that I get off of a social media platform or off of the web, I can then use that generative AI model to generate new examples of that human language, oftentimes indistinguishable from the previous examples that it learned against. In industrial AI scenarios, this can be useful for a number of different things. I mean, you really just have to ask yourself the question of like, what would be useful if I could automatically generate it? A great example would be PLC code, PLC logic. If I expose a generative AI agent to a massive volume of historical PLC logic that's designed under different scenarios, I can then ask it to generate new logic for me to satisfy some problem that I specify it to solve for me, and that's extremely valuable. I could apply it to generating recipes by giving it exposure to historical recipes. I could have it generate things like human interface designs by giving it exposure to ones that have been built in the past. This is really more appropriate for creative or subjective automation where you're just trying to generate a baseline of content to minimize the amount of manual effort that would be expended doing it manually. But what's notable about it is that it's not deterministic. It's not necessarily going to be the best approach for things that are safety critical, must produce the same result every time it's subjected to similar situations. So we have to think carefully about where we use generative AI appropriately in industrial scenarios and where more traditional causal approaches are more appropriate.
Fantastic. Look, I think it's so important to understand the differences when people come to us asking where do I start. I think education, understanding the technology and the terms are so important, so we're at the same base level, so that's fantastic. Yesterday on the main stage, it was really good to hear, you spoke with Cyril about Rockwell's AI vision, like where do we plan to go, where really AI becomes natively integrated into everything we do, from the design to operate to maintain across our complete portfolio. Yeah. Maybe you could help explain a little bit more of that for the viewers.
Yeah, I mean, if you just think about what goes into a highly automated production system, there's a few core components that every system is going to incorporate, right? You're going to have some sort of a design or programming or engineering environment where you design your automation system to begin with. You might be able to simulate it. You might be able to test and validate it, right? Those are capabilities that lots of people use in the manufacturing space. Then you have your operational systems that run in real time. These are controllers like PLCs, and then the sensors that provide inputs to the controllers. And then you have things like operations management platforms like MES for kind of managerial decision making about your production process. What should my schedule and plan be, and what resources do I need, and how to allocate those resources. And then you have maintenance systems that are really concerned about the reliability and condition of your equipment and what you need to do if you need to improve that reliability or improve the condition, like how to do things like preventative maintenance. I think what you'll find is that every category of industrial automation technology can benefit in some way from systems that can learn out of historical data, systems that have generative properties, like that can generate content for you, systems that can adapt as conditions change, solve complex optimization problems. These are all functions and capabilities that AI brings to the table. So our sort of goal is looking at what we have today and reimagining how would we design it differently if we had access to these modern capabilities like learning and adaptation. And then we've embarked on a really comprehensive effort to introduce these capabilities into our portfolio, right? So we're now building design environments that can do things like automatically generate PLC code. We have controllers that have native machine learning functions inside of them, so they don't just execute predefined logic. They're able to learn out of data and adapt control policies according to what has worked in the past and what has not worked. They can make predictions and optimize against complex processes. In the sensing layer, we're incorporating things like machine vision, which gives us a much more robust sensory input. It's almost like adding eyes to the manufacturing process. There's a lot of value in that. In things like maintenance systems, we're making condition analysis integral in our intelligent devices so that if those devices are powering or providing motion to rotating or rotating equipment or assets, they can also analyze the condition of those assets and tell you if it's operating normally or if it's operating anomalously, and then even give you insights on what you should do about it, what work order is required, what materials do you need to fulfill that work order, right? So it's really just the art of decomposing the entire production system and rebuilding it with sort of inspiration from the capabilities that AI brings us.
Fantastic. It's like a holistic version for our customers. It's not just preventative maintenance. It's across the entire spectrum of design, operate, maintain. It's fantastic. And why do you think Rockwell's in such a good position to deliver this to our customers?
Yeah, I mean, so there's a few reasons. I think, one of the things that I think is that we really focus on automation as our core, right? Our strategy is to be maybe a little bit less diversified in a wide variety of different industrial domains and spaces, and really just more focused. Our attention is kind of allocated specifically to the automation and production space, right? So it's what we know well and it's what we can do well. Another reason is that it turns out that automation and industrial automation systems are incredible data producers and data aggregators. There's actually a really interesting statistic that the largest category of data in the world today is actually machine sensor data. There's more machine sensor data on the planet, and it's faster growing in volume than social media information, data that you just find extracted from the web, like financial transactions, and like any of these other large categories of data. And it turns out that one of the single greatest aggregators of machine sensor data is the programmable logic controller, because it's essentially the brain that takes in sensory inputs from machines, executes some logic to determine what output is necessary to actuate. How do I manipulate this machine or adjust it to keep it under control based on what I'm sensing in a given moment, right? So it's both this source of information that we can use to train AI capabilities, because data is really the critical ingredient, but it's also the destination of where the decisions go. If you use AI to determine an optimal course of action or make some sort of interesting decision, it's really likely that that decision is going to be actuated in some way on a PLC. So they're both the source of the information and the destination of decisions. It gives us a really, really great format or a substrate to apply AI onto. Now, when you combine that with the fact that we provide a really significant share of the automation systems to the global market, especially in North America, where we're the primary provider of control systems, it puts us in a really good position to maximize the value that we can create from AI in industrial automation scenarios.
Fantastic. All right, I want to thank you so much, Jordan, for your time.
Yeah, you got it.
I think it provides you, hopefully the listeners, some information as to where we're going as a company. If you're in Anaheim or at the show, please come down and take a look at what we've got to show. A lot of what Jordan was talking about is here. Remember, this is part 1 of the series. Part 2 is coming a little bit later, where I've got Tony Carrara and Oliver Haya coming here to talk about some of the exact products. It'll be fantastic. Talk the products that Jordan was talking about. So thank you very much. We will look at the questions if there was some, but stay tuned for more live broadcasts coming from the show floor here at Automation Fair. Thank you.